Okay, morning all of you. In electrochemistry is the last part. It's nothing but batteries. You well know regarding this device. Batteries means for the main purpose is a source of electrical energy. Source of electrical energy. Okay, means if you want to get the electrical energy, that is possible from only batteries. Now we are discussing how batteries is working and how many types of batteries is there, how they are producing electricity. These all things we are discussing now. So mainly batteries are of two types of. Anybody? Yes, sir. Two types of batteries is there. They are nothing but primary cells and secondary cells. That's only you are telling the primary cells. And another one is secondary cells. Secondary cells. First of all, I will explain something regarding primary cells. It is also nothing but not rechargeable batteries. Not rechargeable batteries. Means we can't recharge it. Use and throw battery. Just once you can use that one, and after electrical energy supply from it stopping, you have to throw it outside. That is called as non-rechargeable batteries. Is nothing but primary cells. But in this type of the primary cells, what type of conversion is going on? So whatever chemicals present inside the battery, that chemical energy will be converting into electrical energy. This is specially calling as a galvanic reaction or electrolytic reaction. Yes, sir. This is calling as galvanic cell reaction. It is only important competitive bits amount. Primary cells is also calling as a non-rechargeable batteries. Here, especially what happening inside the batteries, chemicals will be there. So while you say the chemical energy will be converting into electrical energy, means their galvanic cell reactions will be taking place. Best example for this we have two types. Yes, one is dry cell, and another one is nothing but mercury cell. Mercury cell. Actually, mercury cell we are using in wristwatch and all these things. And what is the secondary cell? You know very well, I think. Yes, it is the rechargeable batteries. Rechargeable batteries or rechargeable cells. This means what? First of all, in this also we have chemicals. First of all, chemical energy converting into electrical energy. That is calling as discharging or charging up. We have secondary cell. We are using a battery. Means the battery is undergoing discharging. Means there what happening? Chemical energy converting into electrical energy. While discharging battery, what happening? Chemical energy converting into electrical energy. That reaction only we are calling as which one? Galvanic reaction. Galvanic reaction. But same battery can be rechargeable. Means what you are doing? Electrical energy will be converting into chemical energy. Yes, you take that battery. Just you can take camera battery, mobile battery. Just again you are putting charging. While putting charging, what happening? Electrical energy will be changed into chemical energy. Electrical energy change into chemical energy means that is nothing but charging. Under charging, which chemical reaction will be going on? Yes, very good amount. Electrolytic reaction will be going on. Electrolytic reaction. Indirectly nothing but electrolysis reaction will be going on. This is important. And what is the example for these secondary cells? A very useful thing is nothing but lead storage batteries. Lead storage cells or batteries. Generally in all automobiles we are using this battery only. And another one is nothing but nickel cadmium cells. But it is a little bit costly. That's why usage will be very less. But lifetime will be very good. That's why the costly automobiles like Benz and Audi, in that they may be used this one. But in normal automobiles they are using lead storage batteries only. So mainly batteries is all of two types of the primary cells and secondary cells. Primary cells means is non-rechargeable batteries. There only one conversion is possible. Chemical energy converting into electrical energy. Only galvanic cell reaction will be taking place. But what are the secondary cells is nothing but rechargeable batteries. So generally we have a rechargeable battery or a secondary battery we have. First of all we are using that one means chemical energy converting into electrical energy, that's calling as discharging. While discharging, which reaction will be going on? Galvanic reaction. Same battery can be recharged. While recharging, what happening? Electrical energy will be converting into chemical energy. That's what we are calling as electrolytic cell reaction. Today we will discuss about the dry cell and mercury cell. of all, I will explain about the dry cell. We are discussing about the primary cells today. Primary cells. How you can construct and how they will produce the electricity. Why not rechargeable? These 3 points we are discussing. Under this first I am taking dry cell I am taking. So dry cell means just I will draw the battery construction and everything. We are discussing about the dry cell. This dry cell is also calling as a Leclanche cell. Leclanche cell or Leclanche battery. See very carefully, it's nothing but normal Nipo batteries and everyday batteries, these all will be there, no, they are under this category only. See, first of all, we have one zinc container we have. See the concept carefully, this is the zinc container, nothing but outside layer. Thus I am writing here, it is nothing but zinc container, cylindrical container. Yes, what is the special of this zinc container is acting as a anode. There preferentially which is going on, oxidation will be going on. So then, is it galvanic reaction or electrolytic reaction? Galvanic reaction. Galvanic reaction is reversed from the electrolytic reaction representation. Generally, electrolytic reaction means anode means positive, but galvanic reaction means anode will becomes which charge? Negative charge. Okay, this whole connection I am showing here negative sign. One end of the battery is nothing but a negative sign. Okay, now with this zinc container, we have to take one special composition has to be taken. Nothing but like paste material we have to take in this one. Okay, we have to take one type of the paste material. We have to take what is the paste material? I will explain here. Porous paper will be there. Did you observe whenever at any time you open the battery? Yes. Inside the battery we have one porcelain paper will be there, porous paper, very thin paper will be there, means they can pass ions through that material. Okay, this paste is what? This paste is nothing but composition of the two chemicals, one is ammonium chloride and zinc chloride. Ammonium chloride and zinc chloride. So what happening here? After that, at the middle of the zinc container, we are introducing a carbon rod, black carbon rod will be there. I think you observe this one. When cylindrical zone will be there, carbon rod will be there. This is nothing but a carbon rod will be there. Yes, this carbon rod is acting as a cathode. Cathode means there preferentially what happening? Reduction will be going on. Under galvanic cell, at cathode is represented by positively charged. Okay, here one metallic cap you are putting to increase the conductivity, or conductivity should be better, efficiency. It is denoted by positive sign. Okay, now it has to be closed like this. So with this contact of this carbon rod, we are taking one more special material we are taking here. I am showing like horizontal lines, not cross lines. This horizontal lines material is nothing but one more special chemical composition. That is, did you observe black color powder will be there. The black color powder means is nothing but manganese dioxide plus carbon powder. Actually, manganese dioxide is not a good conductor. To improve its conductivity, we are using a little bit carbon powder also. This whole device is nothing but dry cell. How it is working? Just you take from here to here some external bulb connection. Yes, you keep it here, one bulb connection here. What happening? The bulb will be going on and glowing. Why? Because where electron will be producing at anode means electron will be passing like this from anode to cathode. The flow of electron already we studied in galvanic cell, vortex cell. So continuously going on till the chemicals has to be converting into involving in the chemical reaction. Once all the chemicals is involved in the oxidation and reduction, the power of battery will be zero. Yes, it's not rechargeable again. So did you understand? Yes, this is the construction of the battery. First of all, what happening at anode and what happening at cathode? At anode means which one here? Zinc container will be the anode. Means zinc plate is the anode. What happening there? Oxidation will be going on. Oxidation means zinc metal, no. Zinc metal will be converting into Zn plus 2 plus 2 electrons. This is calling as a oxidation. Clear. Yes, at zinc plate what we are getting, electrons is coming, that electrons will be passing through this outer circuit and reaches cathode. Cathode means which one here? Carbon rod is the cathode. Yet cathode means carbon rod, there always reduction will be going on. Reduction will be going on. What is involving in the reduction there? Yes, here already what will be there? Here electron will be more, electron will be coming here. Those electrons is pulled by these electrolytic chemicals. What electrolytic chemicals is available here? Manganese dioxide is available, carbon is available, and ammonium ions is available, and zinc ions is available. Okay, all will be contact with each other and just separated by one porous paper. That means through that also the ions will be passing from one place to another place. Okay, now at cathode what happening? Electron is rich on carbon rod. They are pulled with this electrolytic chemical. In the electrolyte, what is utilizing here? Ammonium ions will be taking, plus what will be there, and some other chemicals will be there. It is nothing but which one? MnO2 is also utilizing those electrons, and how many electrons is utilizing? 2 electrons. Take here 2 moles and 2 moles. Then what product is coming? Yes, 2 ammonium ions is becoming like 2 NH3. Anyway, the process is calling as reduction because taking electrons. After that, we are getting manganese trioxide. We are getting Mn2O3. Still, which particle is remaining? 2 hydrogens is remaining and 1 oxygen is remaining. Is nothing but H2O we are getting. So finally, here electrons is producing. Those electrons is passing through this outer circuit. A flow of electrons only is calling as current. Automatically, bulb will be glowing and reaching cathode. This has to be supplied. At somewhere electron has to be produced. At somewhere electron has to be consumed. Then only electron will be moving from one place to another place. That flow only we are calling as current. Okay, here this rod is contact with manganese dioxide and as well as ammonium ions. They will be involving in the reaction, and finally we are getting NH3 and Mn2O3. Yes, what is the cell reaction? Anode reaction plus cathode reaction. Right on here. What is the overall cell reaction from these two? Can you write? Zinc plus 2 ammonium ions. Yes or no? Overall cell reaction plus 2 MnO2. Left side 2 electron, right side 2 electron cancel together. After that we are getting Zn plus 2 plus 2 ammonium ions, 2 ammonium particles and manganese trioxide plus water is coming. Did you observe or no? Means used battery is there. Yes, just once open that one, it become like a paste. Means why? Water is producing in the reaction. Means it's becoming like a jelly, means the battery gone. Cell reaction is over. There is no chance to get the power from the battery. Now this is happening. This is the whole cell reaction in this dry cell. Now why it cannot be rechargeable? It is rechargeable when the products has to be converted into reactant. If it is possible, rechargeable is possible. But it is not possible. The backward reaction is not possible. Why? That is one important point here. Why this battery is not chargeable? In this cell reaction, what is producing here? Zn plus 2 is producing, ammonia is producing, and manganese dioxide is not helpful to us, and water is producing. Okay, now these ions have some special. Anybody, do you know some Ligon concept in D block elements or somewhere previous? No, Zn plus 2 is there. Zn plus 2 has some vacant orbitals, and NH3 is acting as a Lewis base or Lewis acid. Base because donating lone pair of electrons, because nitrogen is already having electron. Each zinc can absorb how many ammonias? 2 ammonias. Yes, it is absorbing like this. Which bond is producing here? Coordinate covalent bond is nothing but dative bonds. That's why the complex is calling as coordination complexes. That will be coming in the D block. Don't worry about that one. Okay, zinc ion has a vacant orbital. This ammonia has lone pair of electron. Definitely what happening? Ammonia can donate the electrons to zinc. Then we are getting a coordinate covalent bond. We are getting the whole species calling as coordination complex. Okay, after that what is coming? Zn is combined with 2 ammonia. Still it has positive charge. The positive charge is satisfied by some negative particles in the mixture. From Zn plus Cl2 what is coming? Cl minus is coming. Yes. We are getting which one finally? Complex we are getting. Coordination complexes. Complexes means highly stable particles we are getting. Okay, if you want to decompose these highly stable complexes, is not happening generally. Even though you are putting charging, this chemical will not giving starting critical. That's why they are non-rechargeable batteries. Simply we have to tell in the dry cell reaction whatever products will be forming, the products will be combined together and will form a stable complexes like zinc and diammonium dichloride. This is a coordination complex, means highly stable complex. That's why even though you are putting charging, it won't break down into reactant. That's why it is not a rechargeable battery. Is it clear? Yes. Now I want to tell one more battery. What is that one? Mercury battery. Mercury battery or mercury cell. Generally mercury cells is very small cells to produce very low voltage. That's why we are using in wristwatch and some different very small sensitive devices. What is the mercury cell device? Just see, very simple. Here also we have to take the zinc container has to be taken. Okay, zinc container has to be taken. I will write here, see, zinc container. Zinc container. The zinc container acting as a anode. There always oxidation takes place. Oxidation means it becoming negatively charged. So that negatively charged shown here as the anode terminal. Okay. In this we have to take at the middle one carbon rod has to be taken. As like previous, carbon rod has to be taken. This carbon rod is acting as a cathode and at top we have one metallic cap. This is carbon rod. The carbon rod is acting as a cathode. Cathode means their reduction. Reduction means it will carry positively charged. Known things only repeating once again. Positive charge. Now, what is acting as an electrolyte in this one? Here also we are taking one special composition we are taking to produce the electricity. It should not touch here. Compulsory, they have to maintain some gap and this will be filled with one special composition that is only nothing but mercury oxide and which one we can take? Carbon powder we can take. Mercury oxide and carbon powder has to be taken or KOH we can take as an electrolyte. Mercury oxide, KOH is acting as an electrolyte. Okay, as like previous, if you give the bulb connection here, what happening? The bulb will be automatically growing because electron will be produced at anode. They are passing like this and reaching a cathode. Anyway, flow of electron is going on, nothing but current is passing to the bulb. That's why automatically the bulb will be closed. My question: what happening at anode and cathode? I want to come to know. What happening at anode and cathode? Just I will write the equation. See, at anode. Anode means you know very well which is anode here. Oxidation will be going on. Very simple things. Which is acting as an anode here, zinc container. Okay, it is already in contact with which particle? Mercury oxide and potassium hydroxide. From potassium hydroxide which is coming, OH minus particles is coming. Okay, then what we are getting? Zinc is undergoing oxidation, is becoming like Zn plus 2. It will be absorbing O from here. After that, what we are getting? H2O plus 2 electrons. Anyway, here oxidation will be going. Okay, at cathode, what happening? Reduction will be going on. Repeated things, no new things here. Okay, which chemicals is involving in the reduction here? At cathode already, what happening? Electron has to be pulled or electrons has to be utilized by available chemicals. What are the available chemicals here? Mercury oxide and a little bit moist is forming. Water is producing plus 2 electrons. What we are getting, anybody? The mercury oxide is becoming like mercury plus 2 hydrogens and 2 oxygens is becoming like 2 OH minus particles. Here what happening? Conjunction of electron is going on, that's calling as reduction. And what is the overall cell reaction? What is the overall cell reaction? Zinc plus 2OH, 2OH cancel. Water is also cancelled plus HGO plus 2 electron is also cancelled. Yes or no? We are getting zinc oxide plus mercury. Which is oxidation? Zinc into zinc oxide is the oxidation and mercury oxide into mercury is the reduction. Anyway, overall cell reaction is the redox reaction. Means somewhere electron has to be produced and somewhere electron has to be consumed. Then only electron continuously moving in the circuit, that's calling as power. Is also not chargeable. Why? Yes, we are getting which chemical we are getting here? Zinc oxide. A very strong solid we are getting. This mercury is in the form of which one? Liquid. Okay, while putting charging, it won't break down into this one. Why? Because its lattice energy is too much. Lattice energy means what? The energy which is required to break the ions from the solid. Yes, I already got it. Ionic compounds are having more lattice energy. Means actually here ions is what Zn plus 2 and Rho minus 2. Between them strong force of attraction will be there. You are putting charging even though the material will not break down into this part. It should not be reversible, means it should not be rechargeable. This is the information we have to discuss under dry cells are of two types. What are the first cell? Dry cell, and another one is mercury cell. 2 is over. Next class we will discuss the secondary cells. Now I will left yesterday some problems. We will discuss the problems. You see carefully. What is the last problem yesterday? Number of electrons something, no? Yes. I will give you one question. You will work out carefully. Current I is 3 amperes. Pass it to a solution, that too silver nitrate solution. We have AgNO3 solution. We have over 0.42 grams is yes, not yes. Now write down one more. Current I is 100 amperes. Current I is 100 amperes is passed through a molten sodium chloride solution, NaCl molten solution. Then we are sending time t is equals to 5 hours. 100 amperes current to NaCl molten solution, you are sending 5 hour duration. Then calculate the volume of chlorine gas liberated at STP condition. Good question. Volume of chlorine gas liberated at STP condition is how much? I told yesterday for this basics. Yes, how much? Liters. Check it carefully. What we can get about? By using time and current, we will get a charge. What is the time here? 5 hours. 5 hours means 5 into 60 minutes. Don't do blindly. But we have to take time is only seconds. Do it. 5 into 60 into 60 in seconds. 5 6 300. 300 into 60. Nothing but 18,000. Yes, no? 18,000 seconds is the time. But what is the charge formula? IT. I is equals to 100 amperes. Time is equals to 18,000 seconds. Anyway, it is nothing but 18 into 10 to the power of 5 coulombs. Is it clear? Yes. Okay, now we know basic. What is the basic we know? As to any electrolytic solution by sending 1 Faraday. 1 Faraday is how much? 96,500 coulombs. Then we are getting how many liters at STP? No. By sending 1 Faraday, equivalent weight, equivalent hydrogen of chlorine will be coming only 11.2, oxygen will be 5.6. 11.2 liters of Cl2 at STP condition. Yesterday I given explanation how you watch. It's a basic. But we have how much charge? 18 into 10 to the power of 5 coulombs. Then gives how much volume? Very simple question. Then volume of Cl2 produced at STP is equals to, do cross multiplication now. 18 into 10 to the power of 5 into 11.2 by 96,500. Comes answer in liters. Check it once. Liters. It comes 10 square comes up means 10 to the power of 3. Then do simplification remaining. 18 by 965 into 11.2. Once you check it, he given 208.91 liters he given. No, you into decimal is there, no? 10 to the power of 3 is there, no? You check it. Correct, no? 208? Yes. Just you work out one more problem. We have next problem. We have copper sulfate solution till science exists. We have copper sulfate solution. Through that time t we are sending 10 minutes. What you are sending? Current I is 1.5 amperes. Current you are sending 10 minutes. Then what is the mass of copper is deposited? So weight of copper is deposited. He given one more point also. Atomic weight of copper is 63.5. If we will not give also, we have to better remember that value. Okay, copper sulfate solution given, time given, but keep in mind time always should be taken in seconds. Don't do blindly. Same previous model. What is given? Solution I is there, T is there, but T in 10 minutes. 10 minutes means 600 seconds, na? 600 seconds. Then Q is equals to IT. 1.5 into 600, nothing but 900 coulombs. We know standard. By sending 1 Faraday, nothing but 96,500 coulombs, we are getting equivalent weight of the copper. Equivalent weight of the copper means how much amount? 63.5 atomic weight by its valency. Valency is 2. Very good, because U plus 2. Okay, by sending 96,000, that much is coming. 96,500 coulombs you are sending means how much copper we are getting? 31.75 grams of copper we are getting. This is a standard, but you are sending just 900 coulombs you are sending, then how much copper is depositing is asking. Simple. The weight of copper deposited under this electrolysis is equals to 900 into 31.75 by 96,500. 0.296 grams. Very good. Like that, you can get it. Okay. Now I will ask you one more competitive bit. How to take the H2SO4 solution electrolysis. H2SO4 solution electrolysis by using platinum electrodes. Can you guess the products? You are taking H2SO4 solution and we are reducing platinum electrodes, means inner electrode. What type of products is producing? You know very well. H2SO4 is decomposing like first, yes, 2H plus particles plus SO4 2 minus. Okay, is a solution? No, already there. Water will be there. The water will be split down generally in the form of H plus plus OH minus, but availability of ion from water will be very less because water is a weak electrolyte. Dissociation will be very less. Now at anode, so means the platinum rod which is connected to positive terminal of the battery, that is calling as anode. So anode carries positive charge. So which particle is coming from solution? SO4 2 minus particles is coming, as well as OH minus particle is coming. But anode preferentially which is going on? Oxidation will be going on. So now my question, out of SO4 and OH minus, which will be more favorable for the oxidation? OH minus is more favorable. Why? Because here only one electronegative is there, here 5 electronegative element is there. 5 electronegative means more tendency for reduction. So less electronegative means more tendency for the oxidation. So OH minus will not undergoing oxidation. Instead of that one, water undergoing oxidation. Yes or no? Because OH minus is available in the form of water. So do it. H2O is liberating like how? To take off O2 na? Yes, off O2 plus